Okay, so reactions with acyl halides. This is just going to be a quick review of some reactions just for some extra practice. So here is, I'm going to be using just ethanol chloride as our acyl halide for all these reactions. And let's just remember quickly what the premise of these is going to be, of this reaction. We know chlorine is a very weak base, and in fact it's probably the weakest base you can have, so it's a very good leaving group. Whatever you're reacting with chlorine is going to leave, you're going to add what you're reacting it with, and if that's a neutral compound, it's going to lose a hydrogen. So let's just take a look. Say we're reacting this with our ethanol chloride with our methanol. Okay, let's do exactly what we just said. We're going to lose this hydrogen here, and chlorine is going to leave. Our end product would look like this. We have CH3. Oxygen's still going to stay there, double bonded, and we'd have OCH3. You would actually have HCl as a side product. That's this hydrogen and chlorine are going to combine to form that on the side, and this is an ester that we formed there. Just to double check, you can see this is an OR group here, right? Which would form here. So this is, it's still not a very strong base, but it is certainly stronger than our Cl minus right there. So the strong base will kick out the weaker base. Let's run through another reaction. Get our ethanol chloride. And this time let's go ahead and react it with water. Okay, what's going to happen? Again, you can see that water would fall into this category here. We're going to lose a hydrogen, and chlorine is going to leave the main molecule. So we lost a hydrogen. We know the electronegative atom is what's going to be doing the attacking right there, if that helps too. So you're always going to have the bond to the electronegative atom in this situation, with the lone pairs, usually oxygen or nitrogen or something like that. So there we go. This is a carboxylic acid. So I'm hoping this helps just to visualize, just to see exactly what's going on of just that chlorine leaving and, whatever we're reacting with adding. So let's go ahead and react it again. Oh, whoops. Getting a little ahead of myself there. Let's react with that. And remember, whenever we are reacting with amines, we always need 2 moles. That second mole just helps to neutralize the acid in this situation. But you're going to have one amine connected. So remember, the chlorine is leaving. All this staying the same here. Chlorine's gone. We're connected to the electronegative atom. Nitrogen in this case, we lose a hydrogen off of the electronegative atom. So one of those is going to be gone. So instead of being NH2, this would just be NH, CH3. Okay, let's, hopefully we got a good grip on that. Let's go ahead and try to do retrosynthesis. So I think these are great for really showing how you understand that you understand how the molecule, or the reaction. Okay. So how did I get this molecule here? Okay, well, and assuming we started with a acyl chloride, we could have started with our ethanol chloride as normal, and we would have reacted it with what? Okay, so we would add an H onto our electronegative atom, right? And I mean, that's it right there. Just take it apart and, you know, throw your chlorine back on there and make it, give yourself the halide to start with. There, and you don't need any acid or anything because these acyl chlorides are just so negative, so reactive that, you know, just a little bit of partial charge here, you know, because this is so partial positive, that is going to react with that. So let's do one more. Let's say we have CH3, O, and let's just say this. How did we get to this molecule? Starting with an acyl chloride, or any acyl halide for that matter. Well, like I said, starting with acyl halide, we'd react it here. OH, we would add a hydrogen onto our electronegative atom, and there you have it. HOH, or water. Yeah, so I hope that helps just to visualize what's going on here. I don't think we need the mechanism for this. I think, you know, the mechanism's pretty easy, but if you guys want that, leave a comment below, and, you know, I can make a video going over the mechanism.